Alright, so what do we do on this one right here? This is example 3. It says find the integral of x cubed minus 3x quantity squared times x squared minus 1 dx. Again, one way would be foiling this out, but it would be a heck of a mess if we foiled all this out. So let's see if there's a simpler way. I have two choices, two logical choices for you. X cubed minus 3x or x squared minus 1. That's both of the quote-unquote insides. We always want to use the one with the higher power. So I'm going to try to see if I can take the derivative of this if I have u equals x cubed minus 3x. So let's give that a try. U equals x cubed minus 3x. Again, I'm going to differentiate both sides with respect to x. So the derivative of u with respect to x would be 3x squared minus 3. I'm just going to note real quick that I could factor a 3 out of that. So that would be 3 times x squared minus 1. Now I'm going to solve for dx by swapping, doing my cross multiplication essentially. So I'm going to multiply both sides by dx, divide both sides by 3 times x squared minus 1. And I'd have dx equals, and then it would be du over 3 times x squared minus 1. I have my dx to plug in. I have my u to plug in. So I'm going to rewrite my integral. It's going to turn into the integral of, instead of x cubed minus 3x squared, that's the integral of u squared. Then I still have that x squared minus 1. Now dx is du over 3 times x squared minus 1. I notice that my x squareds minus 1 simplify. My fraction constant multiple here that I can pull out in front is 1/3. The 3's on the bottom. It has to stay on the bottom. And then I have u squared du. All the variables match, so this is going to be equal to 1/3 times, well, the integral of u squared would be u cubed over 3. Then we have the plus c. Combining this would be u cubed over 9 plus c. But again, we're in terms of u. We need our final answer in terms of x's, so we're going to back substitute. U was x cubed minus 3x. This is that quantity cubed all over 9. Then we have our plus c. That should be our final answer there. How do we check it? Well, go ahead and take the derivative of that using the chain rule. You should and do get the original problem. Alright, so let's look at the next one. It says find the integral of 2 times the quantity 3x to the 4th plus 1 quantity squared with respect to x. Okay, so this looks like a nice U-substitution problem because it's not just x raised to a power, it's something raised to a power. So what do I make u? The rule of thumb is to make u the inside, so let's give this a try. What if we let u equal 3x to the 4th plus 1? We take the derivative with respect to x of both sides. When I do that, I have du dx equals, well, the derivative of 3x to the 4th plus 1 would be 12x cubed. Solving for dx by multiplying both sides by dx, dividing both sides by 12x cubed, would give me dx equals du over 12x cubed. Again, you're just swapping those two values right there effectively. I now know what dx is. I now know what u is. So I go into my integral and I plug that in. This would be equal to the integral of 2 times, instead of 3x to the 4th plus 1 squared, this would be u squared. And then instead of dx, I would have du over 12x cubed. Well, we're running into a little error here, a little issue. What's our issue? You can't have both x's and u's. If you go like this and it doesn't simplify out like it has been the entire time, if there's two variables in there, you have to try a different strategy. There might be kind of double U substitution, there might be some back substitution of this, but the general U substitution, the way that we did it, will not work. So I'm going to go back and look at the original problem all over again, and let's think of, is there a different way that I could have done this? So the original problem was 2 times 3x to the 4th plus 1 quantity squared with respect to x. So we want to find the antiderivative of this. Well, this is only a square power, so it should be possible to you. You should be able to FOIL this out, and instead of doing the chain rule, see if you could just FOIL this out, and let's see what we get. So if I did this, I would have 3x to the 4th times 3x to the 4th would be 9x to the 8th. Then I'd have a plus 3x to the 4th, plus 3x to the 4th, and then I'd have a plus 1. Or really what I'd have is 2 times 9x to the 8th plus 6x to the 4th plus 1. Distribute the 2 would be 18x to the 8th plus 12x to the 4th plus 2. That's distributing the 2 to each one of those terms. So this integral is the exact same thing as the integral of 18x to the 8th plus 12x to the 4th plus 2 with respect to x, and the way we got that is by simply FOILing it out. We don't need any U-substitution or anything fancy here. We're just using the power rule. So this would be 18x to the 9th over 9 plus 12x to the 5th over 5 plus 2 times x. Remember, the integral of a constant is that constant times x. We need our plus c. Do want to simplify a little bit if I can. So I have, 2x to the 9th plus 12/5 x to the 5th plus 2x plus c. Again, you could have written that as 12x to the 5th all over 5. I just wrote it as 12/5 times x to the 5th. Doesn't matter if it's a constant multiple or if you put it as a fraction. Both of those would be acceptable. How do I know that's right? Take the derivative real quick, and we should end up with 18x to the 8th plus 12x to the 4th plus 2, which we do, so it does indeed verify. Let's try another example here. How about find the integral of 5x times the square root of x squared minus 1? Again, kind of looks like we have a product rule here. We definitely have an inside function. It's not just x raised to a power, so most likely U-substitution is going to be used on this problem. Let's give it a try and see what happens. If I use U-substitution, I'd have u equals x squared minus 1, the highest power of x's and the inside of the function. I take the derivative of u with respect to x. Well, the derivative of x squared minus 1 is 2x. I solve for dx by multiplying both sides by dx, dividing both sides by 2x, and I'd have dx equals du over 2x. I now know my green part, my dx, and I now know my red part, my u. I rewrite the original integral. So this is the integral of 5x, and then instead of the square root of x squared minus 1, that's really the square root of u. I'm going to rewrite it as u to the 1/2 though. And then instead of dx, I have du over 2x when I make that substitution. Notice the x's simplify, which is great because now I'm only in terms of u. I pull up that constant multiple. Well, the constant multiple is a 5 on top and a 2 on bottom, so 5/2. I have the integral of u to the 1/2 du. Now I'm able to integrate, so this would be 5/2 times, well, the integral of u to the 1/2, again, would be u to the 1/2 plus 1. Well, 1/2 plus 1 is 3/2. Then I divide that by 3/2, but anytime you divide by a fraction, it's the same thing as multiplying by the reciprocal of that fraction, so u over 3/2 is the same thing as 2/3 times u. Then we have our plus c. Let's simplify a little bit. I'm ending up with 5/3 times u to the 3/2 plus c. We need to back substitute for u. We started with x's, we end with x's. So I have 5/3 times x squared minus 1 raised to the 3/2 plus c. Again, you could convert this back to a radical. I'm not going to. Exponential form's perfectly fine for me.